Today, let's learn how to quickly calculate 333 times 963, and then multiply by another big number. Class, this number actually has a special significance. Now, if I first have 333 multiplied by 1,001,001, think about it. What is the result when you multiply the first two numbers? We call this number the chair number. What is its purpose? Let me explain the principle clearly, and you'll understand. Look, you can break this number down into 1 followed by 6 zeros, then add 1 followed by 3 zeros, and then add 1. Can't this number be broken down into these three numbers? Then, multiply the first part by 333 and the latter part by 963. So, think about what that equals. First, multiply 333 by the part with 6 zeros. That's just 333 followed by 6 zeros. Then, add 333 multiplied by the part with 3 zeros, which is 333 followed by 3 zeros. Finally, add another 333, then multiply the whole sum by 963. This step uses the distributive property of multiplication. Are you following? Alright everyone, look, when you add these three numbers together, what do you get? Isn't it 3 3s at the front and the 3 zeros in the middle? What do they become? They also become 3 3s. So, what do the last 3 zeros become? They also turn into 3 3s. In the end, you multiply by 963. So everyone, why do we call this number a chair number? When this number is multiplied by a 3-digit number, you just write it 3 times. For example, 333 times 100,001. After today's lesson, whenever you see this kind of chair number, you can just write 333, 333, 333. Just write it 3 times, and that's their product. It's important to understand this principle. Now, what do we do when multiplying by 963? When you see a 3, who do you think of? It's related to 9. So let's break out a 3 from the number at the end. In the front, we have 9 3s, and from the number at the end, I break out a 3, turning it into 3 times 321. Look, 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3. I break it down as 3 times 321. Now what happens when we multiply the front part? Doesn't every 3 become a 9? Each 3 multiplied by 3 becomes 9. Then we multiply by 321 at the end. So, what do we do with these 9 9s? If you add 1, doesn't it become a 1 followed by 9 zeros? So, it's equal to 1 followed by 9 zeros, then multiplied by 321, and then you have to subtract 321. Some students might ask, why do we need to subtract 321 here? Because originally, you had this many 321s, but you added 1 extra at the front, so you need to subtract 1 at the end. Now, I'll write the answer to this calculation in these 2 lines. So keep up everyone. In the front, 321 times that, so just add this 321 to it. After the 9 zeros, subtract another 321. So what does that give us? The front part, 32, 32, stays the same, and this one followed by a long string will become 0, then 5 9s, and here it's still a 9. Finally, 1000 minus 321 is 679. Some students might not understand this step. I leave the 32 as it is and turn it into 1 followed by 9 zeros minus 321. That one will have to borrow from the next digit, so it becomes 0, and all the digits in between turn into 9s until the last part, which is 1000 minus 321. Giving 679. So everyone, the final answer to this problem is this number. It's definitely a bit challenging. Please tap the thumbs up and the little red heart below and watch it a few more times to fully understand. If you want to learn more great problems, you can click follow